Well, yesterday we saw how to differentiate exponentials. So the next logical step is how do we go the other way? Integrating exponentials. So if you've got we'll start just with a linear function in the power. So if you've got a linear function, then we'd end up dividing by whatever the coefficient of x is, if you think about it. Of course, that's very limited. I guess a better way of doing it is this. What you want to create is the answer to the differentiation, which was derivative times e to the function x. Once you've got that situation, then we know that'll go to e to the function x. And then that would cover every type that we could handle. So let's look at some. There's one where it is a linear function in the power, so I could just go 1/5 e to the 5x. So perhaps, yeah, okay, for those linear functions, that's probably just quicker. We just look, oh, well, what's the coefficient of x? We'll go 1/5 in this case. If I had thought of it the other way, I would have said, oh, well, e to the 5x, what I really would have liked was 5e to the 5x. So I'll make it 5e to the 5x, but balance it out. I need to put a fifth out the front. I now know the 5e to the 5x will go to e to the 5x, and obviously we get the same answer. But see, now we get ones like this, xe to the x squared. I can't just divide by the coefficient of x squared. So I want the derivative out the front. Well, the derivative of x squared is 2x. We've only got 1x. So if I make it 2x, but balance it out, I need a half out the front. I now know the 2x e to the x squared, that'll just go back to e to the x squared, which will be half e to the x squared. Plus, of course, a constant. It's a linear one, so I could just go 1/9. For some reason, I decided to go the long way on this one. But all right, it doesn't matter. I've created the derivative out the front. The derivative is, of course, 9. Balance it out, it's 1/9. And there's our answer. Square root of e to the x. Got to put it into index form first. So it's now e to the x on 2. I suppose, yes, that is a linear function, isn't it? But again, I've gone the long way. I've said I would like a half e to the x on 2. Balance it out. I'd need 2 out the front. So that becomes 2e to the x on 2. I always like to answer questions in the form that they were asked. So it was asked in surd form. I've answered it in surd form. So it's 2 square root of e to the x plus a constant. Ooh, now of course we don't have a product rule for integration. So we'll have to expand this whole thing out. There we go. And then we just integrate each individual part. And I'm pretty sure I wouldn't have gone the long way on this one. Nah, went straight to, I'll just divide by the coefficient of x. So half e to the 2x minus 2e to the x minus 3x plus, of course, a constant. Again, quotient rule looks like we have to use, but look carefully, similar to that multiple choice one we just did. We can use our index laws and tidy this up. It's actually e to the 3x minus e to the minus x. Be real careful with those e to the minus x's because you get negatives. But this one will become 1/3 e to the 3x plus e to the minus x plus a constant. Let's do a definite one. X squared e to the x cubed. So I would like 3x squared. So let's make it 3x squared, balance it out, put a third out the front. That becomes 1/3 of e to the x cubed. Substitute in 1, substitute in 0. Well, e to the power of 1 is e. E to the power of 0 is, of course, 1. We have 1/3 e minus 1. What about if the base is not e? Well, we saw when we differentiated that it was exactly the same except we multiplied by the natural log of the base. So it's only logical that when we integrate, we'll do it exactly the same except we'll divide by the natural log of the base. So if it was e to the x, it would have just gone to e to the x. So 3 to the power of x goes to 3 to the power of x, but I divide by the natural log of the base. So it's over log 3. You'll notice I've been writing log for natural log. That's just a habit I'm in. Some people prefer to just use ln and make it clearer that we're talking about natural log. I probably should in reality. All right, that shall do us for today.